Hello. Hi. I am Deepak. I work in Kafu as a senior AI engineer, and today I will be presenting a framework that is text to SQL generation. So basically, you can write some text, whatever information you want, and the text gets generated into SQL language, and then SQL can be directly queried onto any other database. So that is the entire project. So there are multiple ways to work on this project. You can use LangChain, you can use RAG, but I chose to use Vana framework. So Vana is an open source framework where it does everything on the back end. So you don't have to do all the chunking and everything. You can just use the framework directly. So I'll give you a very brief context about this, and then I'll show you a domain, and then we will go into the code base. So basically, you train the Vana framework, and by train I mean you do a RAG on the Vana framework using some schemas documentation. All right. So on Vana framework, you train your Vana framework using documentation, using some example SQL queries, and then that is how the RAG is generated for this Vana, and it is then stored into the database as an embedding. And finally, when you are on the application, you just write your language, or like whatever you want to write, and it generates SQL and it can query the output. So for example, this is the UI. Let me write, let's see the bottom three performing pilots in the last 60 days. So currently I'm using the company data, so I can show you only the basic queries. Uh, all right, so let's say it has generated your SQL query, and this SQL query is very much in line with what the current schema I use in my company, because there are certain column names, there are certain like what all tables are there. So it has generated this particular query, and the next is okay, I execute this query and I get the output. Let me refresh it. Probably because I'm using the data is inside a VPC, so that's why the token issue. Or probably I can run the Streamlit and I can show it to you. Yeah, so let me write the same query. Yeah, so this is the query on the Streamlit app, and you get these outputs. Let's say I written the bottom three, so you find the least completed orders by these names, and it directly you give the final, you get the final output. Now I'll go into the code base. Okay, so in this, the first thing is I gather all the data that I require to train my Vana framework. So first of all, I use the metadata, and the metadata by mean is the DDL. So this is my DDL currently. This is it contains all of my table names, the column names, the data types, and the description about all of the column names. So that is the first level of data that I load. Uh, all right. All right. So in this, if I go into the function, you will see that I have loaded, created a connection with the Postgre. I've selected these table, and then finally, yeah. So and this is how I'm loading the metadata entirely from the Postgre database after creating a Postgres connection. The second portion is okay. Once I've loaded this data, and I just initialize this Milvus client. So come to Milvus now. So Vana is a open source framework that generates SQL. Milvus is a vector embedding database. So Milvus they has their own documentation where Milvus is actually integrated with Vana. You can find a documentation of Milvus. This is the Milvus documentation where they have actually integrated with Vana, and you can directly use this. So there are two ways. Either you use the Vana AI framework and you create your own custom database. So that is what I tried in the initial phase I just tried to save all the embeddings on the Postgre database. But it was very slow because you store the embeddings on Postgre and then you again extract from Postgre. So and Milvus is pretty good and it's also very scalable. So I did it with Milvus database. So you have this Milvus class. You just initialize the class. You provide the API key. I've used GPT-4o. I have the API key. Is the API key, and then finally it uses this embedding function, the default embedding function. Now Milvus has the default embedding function as this is the default embedding function. All mini LMs v2. It uses this transformer model to create the embeddings of all the input data passed onto the VANA. Okay, so the first one was the metadata. The second training data is SQL history. The SQL history is nothing but all the example SQLs I can provide as a training. So these are all the more data you provide, the better the accuracy of this framework is. That is the second. The third is document history. If you want to provide some documentation like what should be the format of date, what does completed means, like you can provide a lot of information using documentation. So this is the third. So now we have three different inputs. At line 47, I am just trying to train the RAG model, and it's not training; it's just creating a RAG layer. That's it. They write it as train, but it's not actual training. All right. So in this, I get the metadata. I train using the metadata. Then I get this documentation. I train using documentation. I get the SQL pairs. I train using SQL pairs. That's it. You train this. Now this embeddings is stored. It is stored in the Mulvus database. You have the metadata. You have the embeddings on the Mulvus DB. All right, and yeah, so I can. So now I'll show you the architecture of this, and in the meanwhile, I'll just run this on the debug mode, so I can also show you what exactly is there inside this. All right. Okay, so I've used AWS. All right, sorry, I need to stop this. All right. This was because I was running the Streamlit on the background. Okay, so first of all, I start with the basic. I have created this VPC, this RDS on the AWS, and using this RDS, I have actually created my Postgre. So the Postgre is actually hosted on the Amazon RDS. So that is where I'm actually storing my the metadata. Uh, and then the second is we use Athena SQL base. So in S3 all the files are there as a CSV file, and using Athena you can query those files. So Athena is the second using you can actually get the data, the insights from the data. And then the final solution is hosted on EC2. This is the EC2 instance, text to bot instance, and everything is hosted inside this EC2. And to host this inside EC2, I've just used the Dockerization. So I created a Docker file for this. The Docker file is then hosted onto the Amazon ECR repo. It's uploaded over here, and from the ECR repo, it's directly connected to the EC2. This is the architecture of this. All right. So this is you can actually see how you have these results everywhere. There isn't much. It just shows you that this is the metadata available to you. This is the Milvus client. There isn't much actually to see in this. Now this is a SQL query. It got generated because I run in the debug mode. And all right, so there is one more factor on this. Once you get this output, there is also the other feature in which you create a feedback loop. For example, if you never know if the SQL is good or bad, it's wrong or right. So the second phase of is the feedback loop. Let me show it to you. Uh, in the meanwhile, the app that I was initially displaying to you, this is all hosted on EC2. But because of some security tokens, I cannot execute a query on Athena. But actually, it generates a SQL. And now on the database, there is another table called feedback query. So what exactly happens? Let's say you ask a question over here, like what are the top three performing pilots or bottom three performing pilots. You get the SQL, you get a SQL. But on the front end, you also have an option to say if it is right or wrong. So basically, whatever. So this is it's like a flag. Whatever is the SQL query is right, you can use this query again to retrain your model. So basically, you can create a loop where all this query, or wherever it's correct, it goes into the basic training where we have the SQL history, and then it retrains using these queries as well. All right. So yeah. So this you get this output. Now let's say I just write it's no. Just for example. Anyways, it's correct, but just to show it to you. Okay. So it says it's no is correct. Thank you for the final display. And let's say now I refresh this. So after refreshing, you'll get a new entry over here which says that it's not correct. So this is the overall framework. I didn't use Chroma DB because I wanted to make this more scalable, and Milvus is more good in production. So initially, I've used this Milvus database in the project itself. But if in the future, if we get more data or if we want to make it more scalable, then obviously Milvus can be hosted on a different production server. So that is the reason it's not. I think it's slow to run this. Yes. So yeah. So that is it about this. In the code base, I show you how the training happened, and then after the training is happening, you just provide the SQL query. You generate a SQL, uh, and then it can also validate if these table exists or not. So this is the function where it validates. Okay. So what if it just try to query from a table that does not exist? So I created this another function where it can validate, okay, that it should be among these tables, and then only then it runs onto the Athena database. So that is another function of this. Uh, so this is about about this product. It can be further scalable. The accuracy of this ranges anywhere between 40% to 85 or 90%, but it all depends how robust uh, the training is. If you provide only very limited training examples, the accuracy might be just 50, 60, or 70, 60%. But the more data you provide, the accuracy might increase above 80 or 85%. So that is the reason I've used the feedback loop, because in the beta version, this can be provided to some couple of people in the probably in the analytics team, and those people can test it out for a certain period of time, and based on those feedback, the accuracy keeps on increasing with time. So the more the time goes on, the more mature the solution is. So yeah, so this is about the this Vana framework. There are certain now future improvements on this. Firstly, this can be LangGraph or AI can be integrated in this, and the most benefit of the using LangGraph or Creo AI is that you can actually validate. You can create a new agent that can actually validate if the SQL generated is right or wrong. Currently, there is no agent. It's just a human will be the human will actually see if SQL is wrong or right. But that can be done using the AI agent. So that is the next thing I might try on this. Uh, yeah, I think that's it about this. So if you have any question,
So what you're doing is you're getting the DLLs and putting in the raw material, right? You're generating the embeddings. So how are you planning to handle the modification? So let's say your DDL updating, like you have your new columns added, remove, database changes. So are you trying to plan to have that markup, like any tracking, okay, from this point, my embedding is done. Repeat myself. Thank you. Hey, so my question was regarding the embeddings that you are handling with. So your DDAs, you are handling embeddings in the format design. So let's say the DDA is changed, updated, so and anything can run on those. So right now, I guess let's say there is any updates in the DDA, you are already giving all the embeddings and everything in it and everything. So
Yeah, so yeah, correct. So that is what exactly the problem I was facing, because if there is a change in the schema of the any table, I have to update the metadata in the Postgre, and then the retraining happens again. So I have to delete the previous embeddings or delete the previous training that has happened. So yeah, your point is very correct that it has to be further improved in a way so that you don't. There should be a workaround for this. But as of now, I have not explored that workaround. But there are certain ways which you can do. You can actually check if the previous SQL queries exist in the database or not, the vector database or not, as a metadata, right? And but there is again a problem, because if you change the schema of the table, you don't want the model to train on the previous schemas, because if it exists in the embedding database, it might find you can get it can provide the SQL output of those particular tables. So as of now, I think the only way is you could delete the previous embeddings and then you retrain it again.
Scenario where I needed to generate the embeddings on the data. I don't have an SQL in that case, but some a large amount of documentation as a PDF or Word docs which I need to generate the embeddings. But those I also need to take care of the data which I'm not going to do right now, so I'm regenerating all the embeddings. So that the data of that change, so that we don't need to regenerate the whole embedding again because it's time consuming,
Yes.
cost, and a lot of variations. Anyone knows here about the data change of the embeddings? Please.
Hello.
Actually, it's quite interesting because recently I tried to explore language there. And I was wondering, no, so,
So
okay, so just on that, right, on data, especially documents, this is not a new problem, it has nothing to do with GenAI. So there was this topic previously, 6.5 years ago, before I joined Database, I was with another company, recruitment firm. So you would get resumes and CVs of candidates, right? And we had a massive Elasticsearch cluster. And the way we would load everything in is, we would take and then scrape everything off of that PDF in the Word document and then dump it into an Elasticsearch cluster. How do you do a delta? Well, guess what? The only way is you run night job and then scrape everything and dump it again. Because there's no way that you can scrape the exact same document content twice, right? And then compare both of those things together. The other option that you have is you would probably want to have an intermediate format. So every document that comes in, probably you parse it and then move it into an intermediate document format. Like think markdown, the mathematics, right? Yeah, markdown. Because the idea is that you want to bring it to a point where you can take it to a different and then say, okay, based on this tip, this is what I can do. But it's hard because again, it's tedious and stuff. So you probably want to still have as a fallback that what's the best way for me to do an IT job for my embeddings, but then you're also doing a lot of work on that embeddings data which needs to be written. So no straightforward answer unless somebody has solved it already.
I haven't solved it yet, and I don't want to give any half-baked answer. So I need to explore this. But as of now, I'm just retraining it again with the new embeddings if the schema is changed. And not everyone has the access to retrain this model because it has to be by only certain people who should retrain this model, because the more the retraining happens, the costing will be there, and someone can do a wrong retraining as well. So yeah, so that's it. Yeah. So yeah, just to show you that the last entry got updated under the poster with a false flag. So that is how the feedback loop happens. See, this Vana framework, you do not have a lot of control on the Vana framework. If you do it using LangChain or LangGraph, or you do create your own custom rack, you might be able to create some sort of logic where you can do this thing, right? But Vana, you don't have a lot of control on Vana. It's a predefined library that I'm using. So yeah, so it's open source. This is a GitHub link for Vana, so you can directly use this, and yeah, so it's open source. See, one AI is a framework that converts, that creates a RAG. CrewAI is like a multi-agent, right? So you can use one AI inside CrewAI. Like one of the agent can create a SQL or create an embedding. Other agent can actually validate this, right? But I did not compare it against it. But that is what I'm trying. The next I'll have to create this multi-agent in the next, what my plan is, so that actually everything should be automated, the validation, everything. Yeah, it's only for SQL based track. So this is only for SQL based track. You can explore this GitHub, and it's only for SQL generation. Okay, so for the first question, I'm not very sure because I followed this documentation of Vana. So this is the Vana documentation, but I wanted to integrate this. Is it this? Okay. All right. So I haven't not. I don't remember actually if I've explored this, or I might have explored this, but I haven't used this. Secondly, I do not want to make it as a chat thing. I want to. Okay, I'm not very sure about this. Yes, I haven't worked on visualization yet because I need to perfect the solution. Yeah, yeah, I haven't worked on any of the visualization as of now. It's just generating the output. It's just creating a feedback loop. That's it. Visualization is not currently. I've not touched that part. It is not fine tuning a model. The model, you already have the GPT model as a backend. It is just creating. It is using all the metadata that you have, SQL or SQL examples or documentation. So it takes the prompt as an input. The prompt is something that I provide, like I want a certain question, right? And then it extracts the most relevant chunks from the embeddings using the so whatever embedding is us, whatever. So not, yeah, you can say that. So it extracts the most relevant chunks from the database, and uses those the database the chunks from the database. It passes to the LLM model, and that LLM model creates a SQL query for you. So basically, the LLM model, that GPT or DeepSeek, that creates a SQL for you. But as an input to the LLM model, you're providing the question what you want, and and then and some training examples, that this is how the and the training examples are mostly like based on your. Yes, yes, yes.
Okay. And have you tried to use structured, like when you're training the schema on the DDF, have you tried to use schema which has relations or only flat tables?
So see, if you want to train using relations, there the feature is there. You have to provide all of this in the documentation and also into the training example. For example, you want to write in a documentation that this the primary key exists in this particular table and it acts as a foreign key for that table. So that should come into the documentation. The second part is you create some training examples where you are doing some certain inner joins or left joins, and you create a more complicated query. So all of this will be then passed into the rag layer, and that is how the embeddings will be created. So using this, this will be improved. So this is how it is done. I have not used any left join as of now. I've just used a single query, but this is how it works, because that is what I tested on a rough notebook. So
So it's very interesting actually. Thank you for the demo. The training examples, is there a limit? You have to clean up the whole training examples. There is some context when you have to do the training, or there is no limit on the number of examples that we give to enhance the performance of the generation of the SQL.
as per my knowledge, there is no limit. You can retrain it as multiple times. The database.
You can add as much as possible.
Yes, yes. So that yes, yes. So that is about when the more data you provide as a training, the better accuracy is. If you just provide like 10, 20 examples, the accuracy might be just 70%. But you provide like thousands of training examples, the accuracy might go over 90%.
But I'm worried about the context window. Does it use that every time you
So so
give more examples?
so for context, so that is where chunking happens. So it uses this default embedding function. So in this default embedding function, it is actually creating chunks first. So it might create a chunk of, let's say, only 100 tokens, and that is how it is storing everything in the vector database. So in the database, you have some certain chunks saved, and into the LLM, you passed only the relevant chunks. So the context window, it is taken care of.
Thank you so much.
No problem. Thanks. So this is documentation for Wilbers.io. If you want to go through it, it has everything about how the default embedding function happens and how the embeddings is stored. So, so sorry, just I understand correctly. You mean to say, what if someone updates your database or deletes the database? De- you delete and update. See, right. I believe it should be like Vana should do this. If you provide some documentation and training of updation and deletion, it has to just, so Vana is just creating a output as a SQL query. If you provide this training as you update or delete, it will do that. It should do this. Uh huh.
not sure if the functionality or options
Okay, so if it is not there, because I haven't used updation and because we don't want to update the database using the front end, it's very risky. So haven't explored that. In fact, I was more concerned about if someone deletes or updates something in the database. So there has to be certain rules from AWS. But if it is not there, then I also have to explore. I was under the impression that it's there, but thanks for letting me know as well.
all right, sweet. So with that, we end the questions. I saw a lot of questions for Deepak, so thank you, Deepak. Thank you for the demo.
Thank you.